Hello, this is Lindsay Boggs, and this is the video for Project 4 within GPE 104 Super UAT Brothers. This project needed to be a platformer, use 2D gravity with a rigid body 2D, detect if player was grounded, making sure they can only jump a set number of times, i.e. double jumping before they have to touch the ground again, using animations, sounds, music, the sound of music, loading new scenes, having a start screen, victory and loss screens, checkpoints, responding to those checkpoints when they die, and then of course an additional 10% of creativity. In the checklist, they have to move left and right, of course use gravity, detecting if they're grounded, jumping a set number of times, of course using the idle walk and jump animations, having different sounds set for the little details of the game, when they are dead, when they get hit, etc., picking up items, having music for different scenes, using multiple scenes, including start, victory, and fail screens, checkpoints, bug and error free, and then commentation, of course, and our extra tidbits. So let's go ahead and get started, making sure that everything's set up appropriately here. Okay. So we will go ahead and start with the way the player would experience the game, which is with the main menu. So we have Penguin Hopper. It is a Text Mesh Pro object, once again, within Canvas, kind of coming back from the last project that we did. Not that it's a duplicate, but it's the same concept that we learned in the last project. Anyway, and as well as buttons and that sort of thing that's going to allow us to change scenes. So if we hit play, it's going to call the, let's move this down a bit so we can see, button function manager start level 1 is the function that it calls. So I have a button manager object within this scene, which just has a script on it. So if we go ahead and open up that script, I wonder. Nope. Oh, wait, yes. It can be that easy. Alright, I was going to go dig it out of the files, but if we can just grab it here, that'd be even better. Alright, while that's opening, I'm also just going to show that the quit button... Oh. Come now. We must wait because Unity is frozen. Right. Okay, new plan. Let's go ahead and show off the build first, and then we'll go back and look at how the code works. So, if we come into builds, we'll see that we have a build right here. And we'll go ahead and run it. Alright, so here is our menu screen. It is called Penguin Hopper. We have a play button and a quit game button, just to show that the quit game quits the application, as it will do also with the game over screen and with the victory screen. It's the same function. So here's our first level. We have these spinning coins here, and they count themselves, and then they set this UI in code so that the designer or artist or anybody else doesn't have to go through and actually count out the coins. This is our checkpoint. It has a trigger box on it so that you don't actually have to touch it in order to set one off. You can simply walk near it. You can't jump over it. It's a tall vertical piece. We have 3 lives here that we can lose a life only by falling. So this game is kind of geared for a younger crowd, so it's a little bit more forgiving. So for example, if we were to jump on this spike, it's going to push us up and back, depending on which way we're facing. So if I were to come over here, it would toss me that way, and then if I were to fall, I'd lose a life. But I respawn at this checkpoint. Also worth noting is that this checkpoint is already triggered, so therefore I can't go back and reset it to this checkpoint. It's always with the most progressive checkpoint that the players hit, and they can't hit a further checkpoint and then come back and hit a more recent checkpoint, because they have to hit this point. There's no way for them to get past it without hitting it. Okay, on that note, before we go any further, we'll have a look at animations. So we have our idle animation. We can move left and right, as we described in the requirements. We can jump. We can double jump. We cannot triple jump or anything like that. 2 is the best we got. We also have a hurt animation, as you can tell. Let's see. Jumping we mentioned, and then our jumping animation also doubles as our falling animation when we hit a fall zone, which I'll go into in a bit when that finishes opening up. We have different sounds. We have a sound for jump. We have music going in the background, of course, as well as on the title screen, the victory screen, the game over screen, as well as different jingles that trigger when those states, or when those events occur, I should say, not states. Anyway, we also have a sound for when the player gets hurt. And the reason that he doesn't play the animation every time is because it's based on whether or not his X movement is 0, like based on the controller input. And it sometimes is still decreasing, so we won't mess with that too much. This injured sound is actually the same as the jump sound, it's just been tweaked a bit in the inspector for its pitch. I just drug it to a higher pitch, but it's the same audio clip, which is kind of nice for repurposing things. And there's also a sound when we collect our coins as well. Alright, since we only have 1 life left, let's go ahead and get a game over, which occurs when we've lost all of our lives. We don't get to play with 0 hearts, but it will trigger only when the death audio is done playing. So we will die, audio concludes, and then we have game over. From here, we can hit play again, which will launch a completely new game, or we can go to main menu. I will go ahead and hit play again, and you can see we have a fresh slate. And we will just try and speed through here as quickly as possible, so I can show you the victory screen. Oops. Alright, and then we have our end zone, which what that did was it stopped level music, played its own music, and then at the conclusion of that music brought us to the victory screen, which has its own thing here. From here we can quit game, go back to the main menu, or play again. We will go back to the main menu, and then from here play again, just for one more run through. Oops. Okay. Alright. Just because I wanted to not die at my own game. Alright. What I wanted to show here was that the level music stops and then this plays. But I had forgotten to point that out ahead of time, so here we go. Alright. We can go ahead and quit game. And that is the build, and now that Visual Studio has opened, we can go through the code. Right. So, going through things as a player would experience them, so starting with the main menu. As I'd said, we have this button manager right here. It is located in the scripts folder, in the managers folder, and then we have here our button function manager. So, this was done for the ease of just getting the I suppose, what's the word, relevant functions into our scene. Never mind all of that. Oh, well, that was just some things that I was trying to do there. Okay, so here's what we have. We have a start level 1 function, leaving room for, perhaps other levels within this game. But right now, we only have a start level 1, which is going to be for play. And then we also have a quit game function, which is just application.quit. In the other scenes, we have start main menu, so in the victory and the game over screens, and I believe that's it for our button manager. Just those 3 buttons. I thought that was going to be more impressive than it was. Anyway, next screen. Scene. Level 1. Okay. So here we have some UI components, as well as the actual level. So we'll go through UI to start out with. The player has 3 lives, and these are actually managed by a lives manager within scripts managers. Life manager. Okay. So this script holds 3 public life class objects, which each of these is a prefab, because they each contain their own life script. Therefore, we have these 3 unique instances. At every frame, we check to see what the player's life may be. And so when their lives are greater than or equal to 3, that was just done for efficiency. And if I ever change it to be greater than 3, I'll have this kind of set up already. Anyway, we set all of these to true. And when we have 2 lives, we set these first 2 to true and the last one to false. 1 life. The first one is true, the last 2 are false, and then of course lives equals 0, they're all set to false. This function is called within this object itself. So if we go into scripts gameplay, life, each of these objects contains this script. It has an animator, which is simply on or off. It's 1 frame a piece. And they all start on. And then when we set life within that life manager script, we take in a Boolean as a parameter. And if life is true, then we play life on. And if life is not true, then we play life off. And it's as simple as that. So, going into the coin counter, if I can find my canvas. Okay, there's our lives there, drag into our life manager, and then here's our coin counter. We have a coin count, which is this here, and this 25 over 25 is just a placeholder. This is all updated within code. And the star icon is just a stagnant piece there. So, let's go ahead and have a look at the coins. So each of these coins collects, of course, has a collect item script, which was one of my extra pieces here that I wanted to talk about. Where did I write about it? Right here. Collect item script is dynamic, public dropdown for future pickups. So what I did was I programmed with the intention that this script would be able to be used on more than just this pickup, thereby condensing the amount of scripts that we have and making it easier for designers to simply put a collect item script rather than a unique script simply for star coins, and being able to select what kind of a pickup this is. So, looking at this script, which is on our coins, if I go ahead and pick up one of them, this one, it has a rotator script, which is just rotates it, that's fine. But it has this drop down, so I can click star coin, life coin, speed coin, or invincible coin. Right now, only star coins exist within the game. But in future iterations, those other things could be implemented and would be much easier to implement since they've already been kind of primed or allotted for. Where did my studio go? There it is. Okay. Right then. So that is set with this enum. And we have a enumerator of item types: star coin, life coin, speed coin, invincibility coin. And then the thing that actually creates the drop down is this public item type pickup, which is, as you can see, what this is labeled right here. All right, so when this script becomes awake, we set our total star coins to 0. And this was done because we immediately start counting them in our start function. I ran into an issue while creating the replay loops, so those play agains after you've already played once through, where the coins continued to count themselves because I use a static, I believe I use a static, yes I do, public static integer called total star coins. And because this space in memory is shared by all coins, they all add themselves into this local space. But when the game is restarted, it just continues to add into that space without this piece of code right here. So every time awake is called, which is each time this screen is loaded, we call awake, set them to 0, and then we recount them so that we never have a higher count of coins than the number of coins that we actually have. So that's why that is set up in that manner. Secondly, right, when we would incorporate these other kinds of coins, they would have a similar pattern set to them. So if it would be a star coin, add to that count. If it would be a life coin, add to that count, etc. To use within the script. But since we only have star coins for now, that's all I've coded out. And then when the player enters this trigger, we're going to do a couple of things. Firstly, we're going to play a sound within the audio manager. I did try to use that play clip at point, which we learned in class, but it ended up distorting my sound a lot. And I did some reading, and it said something about the Doppler effect, but no matter what I did, it was like really disgruntling. So I did it in a way that I knew worked. But anyway, and yes, I had it set all the way to 2D sound, and I turned the Doppler effect off, and it was still giving me some trouble. I also tried playing the sound at the camera, but when the player would continue to move, jumping along their level, it would still be pretty distorted. Anyway, so we go into the audio manager, and we have this child object right here, Rainbow Coins Audio, and I've just drug in this audio source. I did find another way to be a little bit more efficient about that later on, but since it worked, I left it as it was. And then we are going to go ahead and check to see if this item is a star coin, because as I'd said, we can use the script for other objects later on. And if it is a star coin, then we add to our count, which is a public variable within the game manager, and then we also update our GUI text, which takes the Text Mesh Pro, uses the set text option, takes the star coins that we've collected as we just incremented them right here, and sets that as the numerator, and then of course we have a backslash, and we have our total star coins, which we got from this script as they counted themselves together into that static integer variable, and writes that as a string. So we get our 25 out of 25 when we've collected them all, etc. Because we have our coins counted here for their total, and our coins counted within the game manager for how many we are currently collecting. And then lastly, after we have played our sound and incremented our count, then we destroy this object, which is the collectible item in this instance of the game, the star coin. So there's that. We'll go ahead and close these since we've talked about them, but I don't want Studio to close, so I'll just leave that one open. Okay, next to encounter is the checkpoint. So we will go ahead and open up our checkpoints group and have a look at this. If we look at it in the scene view, we can see the box collider, and you can see clearly how the player cannot escape ever triggering this checkpoint. So they wouldn't be able to, example, check this one and then go back and check this one. It's not going to happen. Anyway, They have a checkpoint script on them as well as an audio source. Since we won't be destroying this object, I do very much prefer using audio sources like on the object as opposed to playing them at clip or playing clip at point. Anyway, let's have a look at the script. Open. And it says, we have an animator, of course, because it starts empty, and then it has a, well, I should say off, and then it has an on animation once we've triggered it. So we get the animator component within our start function, and I've started to use this hide inspector to kind of conceal things from designers and artists that they don't need to be bothered with. So it also keeps the inspector a lot cleaner and a lot easier and more efficient to work with. Anyway, we're just grabbing our own animator. We also have a private boolean to see if this checkpoint is checked, true, false, and then of course the audio source component called mySound. So we go ahead and set those by using getComponent within the start function for the animator and the audio source, and we start the game with the checkpoint being false. So we go ahead and set that boolean. And then when the player triggers this collider, which is that big tall box that has disappeared because I clicked off of it, that one, then we are going to check to make sure that this object is the penguin. There's probably a better way I could have done this with checking the tag to make sure it was the player, but because I am using a player controller to control this pawn, this was simply the way that I programmed in this assignment. So I take that other collider, I look at the game object, I check to see if I can get this penguin pawn component, in which case it is the player. And if it's not null, so if they actually have this component, then we progress to the next step, which is to check to see if this checkpoint has been checked. And if this checkpoint has not been checked, or it's false, then we're going to grab the location of this checkpoint so that we can update it in the game manager and respawn our player at this point when we die. Ooh. Did I show you all of the checkpoints in the build? Like how they update? I might have to go back and do that. Okay, anyway, we update it in the game manager by grabbing this position, loading it into, well, actually I have a function called setCheckpoint, which then does that part of the code within the game manager itself, which it takes the checkpoint variable and sets it equal to this vector3, which is this transformed position of this object. Then we set our boolean to true, so isChecked equals true, and then we have our feedback loop for our player. So we go ahead and play the animation, so turn this checkpoint on, and get a little yellow star in the middle, and then we play the sound. So it's simply mySound.play, because this is a audio source, so this function is within the audio source class. And that's it for the checkpoints. Let's go ahead and talk about these invisible objects, which have a make invisible script. I won't even open the thing for it because it's right here. We simply, on start, take the sprite renderer and turn it to false, so that you can work with it within the editor, and then when you go to play, or when you go into game mode, well actually, if you were to hit play in game mode, it would turn the sprite renderer to disabled upon the start function of the game. So, or I should say when start is called. These invisible objects right here. We have a invisible wall. It's more of an invisible ceiling in this instance because this cliff would register as ground when the player is jumping, so they can kind of Skyrim their way up the mountain, but this ceiling blocks them from doing so. So that's why that is there. So that's not very impressive. It's just a sprite object with a collider on it so that we can't climb up and out of the game. Secondly, we have these red ones over here, and these are fall zones. So if we open these up, they have a box collider on them, but it's set to be a trigger. and that trigger operates within the script. It also has the same make invisible script as the walls do. But what's really important on these is this fall death script. So we'll have a look at that. And it has its own sound for when the player falls and crashes and burns. And that's its only variable that it declares. If we expand this out just a bit. Okay. On start, we set the sound be equal to the audio source component that's on this object, and then we are constantly, we have a function for onTrigger enter 2D. And first thing we're going to do is the same thing that we did on our checkpoints, is to check to see if it is the player that has crossed our bounds, because if not, there's really no sense in doing anything else. And if it is the player, then, or if the component is not equal to null for a penguin pawn on this object, which it is the player in that instance, we're going to disable the player controller, because I don't want the player to be able to guide their way around. Not that it's that important, but I want the fall animation to play. And if the player has control of the controller, he or she will be triggering animations, which is undesirable. So we disable the controller through the game manager, and then we are going to play the fall animation on our penguin pawn. So this other game object, that penguin pawn component that we had on it, we grab the animator and tell it to play the jump function, or jump animation, I should say. Thirdly, we stop the level music that was playing so that we can play our own, which it's more clean and distinct, and the lesser amount of sounds we have playing over the top of each other, the better, in my opinion. So we stop the level music, we play our own death sound, and then we decrease the player lives within the game manager. And once those lives are decreased, then as you saw before on our life script, which is constantly checking to see how many lives the player has, it will update the animations on our hearts within the GUI. Then, after we've done that, when the death sound is finished, we're going to reset the penguin pawn to the last checkpoint, which was stored as a variable within the game manager. And we're going to do that after that is finished. So I did a bit of research to find this function, which I like it a lot. So you will see this come up. It is called invoke, and it takes a function as a string, which is interesting, and it will call that function after a set number of seconds, which I can't remember if this is a float or an integer, but I know that it's in seconds. Interesting, because I tried to at first call a function within the game manager, but it couldn't do that. So what I ended up doing was writing that function into another function within this class and calling that with invoke, and it worked splendidly. So if we go down to invoke game manager checkpoint, it's right here, which is simply game manager.instance.load checkpoint, because this is a function within the checkpoint within the game manager that couldn't be accessed with this function, but I made a workaround, so it works very cleanly. And of course, I'm putting invoke here so that I know where and why I've created this within my code. So it's very clean and organized, and it makes sense. Right then, so we only do that if the player's lives are greater than 0. If the player's lives are equal to 0, or less than, or anything else other than being greater than 0, which is simply less than or equal to 0, then we call a different invoke function, which is invoke game over, and once again we play that after the death animation has finished. There is a function on clips, on audio clips, which it returns a boolean for is playing, and for whatever reason it wouldn't work. So what I've done is I've actually waited for the length of the clip rather than checking to see if it's still playing or not before I call this function, which it was perfectly fine doing that because it allows it to play through, and then we do what we need to do. Next on the list, I ran into another issue where the player, for some reason, even though we had disabled the controller up here, this one right here, even though we had done that and set the animation to jump, the pawn was still idling or doing other unintended animations after passing through. And the reason I believe this to be happening was because these two things were called in the same time. I really, really, truly believe that it shouldn't matter, but I couldn't come up with any other logical explanation. So I made a on-trigger exit 2D just to be doubly safe, and it fixed the issue. So that leads me to believe that if it's not correct, that this is very closely related to why that issue was happening, because this fixed it. So once again, we check to see if our collider is the player or the penguin pawn, and if it is, then we just call our jump animation again, and that fixed it. Okay, next thing on the list within this thing. Oh, we did talk about that. The invoke checkpoint and the invoke. Oh no, we didn't talk about our scene manager yet. Okay, so scene managers are new with this project, and loading and everything for scenes. So if we have any more lives left, when we've played our death clip for falling, then we're going to load our game over scene. And this is located within Unity Engine Scene Management. So that's how that works. This string needs to be exactly the same as the scene. So that's a little sketchy in case somebody renames a scene, but we do what we have to. Okay, getting close to the end of this level elements things. Oh no, I'm not. I gotta talk about the player and about all of that. Okay, let's talk about these spikes. Spikes group needles. Okay, so they have a damage zone on them. The original intent was to use this for other objects. It ended up just being the spikes. But this is what it does. It has its own sound. So you could put this on other things other than spikes and have a different sound play, which should be totally valid. And we check to see, once again, if this penguin component is on the object, in which case it's the player. And this penguin pawn, well, not this one specifically, they would all have them. Penguin pawn would have a Boolean on it called isHurt. And so we grab that Boolean off of the penguin pawn component from the game object from this other collider that entered here, and we set that Boolean to true. And then we play our sound, whatever sound that is. Because the penguin pawn has its own way of handling the physics and the animations. So let's jump over to the penguin. Okay. And we'll have a look at the penguin pawn script. We can get rid of our checkpoint script and the button function. Hey, yes, it's fine. And that. Okay. So, following up with the isHurt Boolean first, since that's where we're coming from, and then I'll go ahead and explain this from top to bottom. When the pawn is hurt, it's right here. So this is within our move function, which is called on every frame through the controller in a fixed update. If hurt is true, then we simply set our animator to play damage. We add force up and to a direction to our rigid body 2D, but we start by going up because whether we're facing left or right, we're still going to be going up. So we go ahead and do that times a designer-friendly hurt height times time delta time. And then we're going to go ahead and move over slightly, but we're going to check to see which direction we're facing. So if is flipped is false, then we are facing to the right, and we want to bump them backwards. So we're going to bump them to the left. So we go ahead and add force to the left times a hurt distance. So hurt height is how high they go, hurt distance is how far, left or right, times time dot delta time. And then if they are flipped, then they are facing to the left, and we want to bump them backwards, which would be to the right. And then once again, it's hurt distance times delta time. After we've done that, we will set is hurt to false so that we can break out of this if statement and he is not completely hurt for the rest of the game. Alright, so now that we are talking about the penguin pawn, let's talk about the penguin pawn. Okay, excuse you. There's our penguin pawn. Okay. We have our hide inspector is hurt, of course, because designers don't need to do that. That's a code purpose. It needed to be public so that we could access it through our damage zone script. Then we have a public float, which is designer friendly, called hurt height, as I described to you like 5 seconds ago, as well as the hurt distance. We also have a animator state info to tell if something is concluded or not concluded. And then we have an audio source jump sound, which we play when we jump. And we have a public boolean called uses player pawn, I believe. Okay, yeah. I'll get back to you on that one at the end of this tiny segment. Let's describe this bit first. Okay, so when we become awake, we play our base awake function on our pawn script. Because we use inheritance within this project, I'm not sure if that counts as a extra or not, but I try to take everything that we've learned from previous projects and apply them to our current projects for practice. Goodness. I need my pawn script. Pawns. Thank you. Okay, penguin pawn inherits from pawn. The foot trigger was lumped in with them because it's related to pawns. Anyway, so here's our pawn class, and we have an awake function, which is inherited by the children of the pawn class, which in this case is the penguin pawn as an only child. We grab our rigid body component, which is public, and we go ahead and set that to the one that's actually on the object, and the same thing for the animator. So nothing too fancy on these awake functions, but this is important because awake is called when the level loads, and when this was previously set to start, it was yielding all kinds of errors and telling me not to destroy the pawn because it was hooked up to all kinds of things, and it was a mess. But changing start to awake fixed all of that. So when we come over here, we call our base awake function, and then we start our penguin things. So is flipped is going to start off as false because by default he's facing to the right. And that's how all of our animations are based off of. Everything faces to the right. And then we start to load our variables. So we have our jump sound, which is the audio source on this object. And this was rehooking up the object to the player pawn. Actually, I have a sneaking suspicion that this is irrelevant at this point. I was doing this as a workaround when I was destroying or trying not to destroy things on load, including the game manager and the player controller and this penguin. But what I discovered was that actually destroying them on load and simply recreating them when the scene is loaded ended up working much more smoothly. And I could see where progressing to a level 2 or something, not destroying on load, would be just fine, and you could place those objects at locations within code. But wanting to start over from a clean slate, not destroying them was more trouble than it was worth. So everything does get destroyed in this project and then recreated. Just a heads up. Anyway, then we have our move function, which is called by the controller. So we can go ahead and talk about these at the same time. Controllers also use inheritance, like the previous projects. So we have a controller script and a player controller script. So on the controller, it's simply grabbing a pawn for any kind of controller, be it player or AI. We don't have any AI entities in this game, which is a good thing. But that's all that does. So our pawn variable comes from our controller parent class, which grabs it. And then we start to differentiate ourselves. So this horizontal move is based on a different kind of input than I've used in past projects. Before I was using like left and right as button down, like specific keys, but now I have it set up on an axis. So rather than get button down, we're getting an axis. Because I wanted to practice with that. So that's what it does. This yields a float between -1 and 1. -1 being all the way to the left, +1 being all the way to the right, and 0 meaning that nothing is being held down, but it oscillates between them. It is not snappy. It's like a sine function. It goes up and down in a wave, which is important to note for our animations. So, that said, we also have a public boolean called jump, which we're going to pass into our move function for our pawn. Right then. Sorry. Okay, on the update, we're going to be checking for our horizontal axis and taking that as input, funneling it into our horizontal move, float variable. And then if we press the jump button, which is a get button down, then we set jump to true. In our fixed update, we are going to call the move function on our pawn. So we have pawn.move because all pawns will have a move function, be they penguin or not penguin. And if they're not penguin, then I need to do some revamping with some other pieces of code, but we're not going to talk about that at the moment. Anyway, we call our move function, which takes in this float times that fixed delta time, and then also a jump boolean. After we call the move function with our whatever value of our boolean, we're going to be setting jump to false, so that only fires on the frame that it is called, and you're not continually pressing jump frame after frame. Right then, so the player controller is actually pretty small, and everything else, the magic, happens in the pawn controller. The magical move function, which makes up almost the entirety of this piece of code. Anyway, first thing we're going to do is face the correct direction. So if our X movement that we've passed in, so that's that horizontal movement, is less than 0.0 as a float, in other words, they're moving to the left, and is flipped is false. So the player is currently facing to the right, but the player would like to go left. So we're going to flip the entire player object. I don't like that, whatever it's called, sprite renderer flip, whatever, because, yes, I have a capsule collider on this pawn now, but previously I was trying to use a polygon collider, and it would mess with the collider because it would only flip the sprite and not the rest of the object. So we are flipping the rest of the object because if I wanted to use a more complex collider, this would get the job done, and anything else would mess it up. I feel very strongly about this. So we're going to be taking our transform.localScale and setting it directly to a new vector3, which is simply the -x of that local scale, which flips it over, and then it takes in the same y and the same z coordinates. Not that z is even relevant because it's a 2D thing. But it does it. So that just flips him over in the x right there between positive and negative. And then we update our boolean is flipped to true. Now, the opposite. If the x movement was greater than a 0.0 float and is flipped was true, i.e. we flipped it here since they start off at false, then he is facing to the left and he'd like to go to the right. So we're going to flip him back doing the same thing by setting his local scale to itself, except that we're taking the x and making it negative, and then we're going to take is flipped and set it to false. So after we have done that, we're going to check for these hurt animations. By the way, the order of go within this code block is very important. So first we're checking for direction, and then we're checking for these things, so that everything ends up looking appropriate. Anyway, once he's facing the correct direction, if he's hurt, then we're going to play the damage animation from our animator, and then we're going to add force upwards to our pawn, as I described before while talking about the needles or damage zone script. Then we move him over slightly based on his flipped Boolean value, whether it's false or if it's true. If he is flipped, then he is facing to the left, and we want to bump him, or excuse me, if he is not flipped, he's facing to the right, like he is here, and we want to bump him backwards, just to the left. So we go ahead and do that with vector2.left times hurt distance, which is designer friendly, times time. And if he is facing to the left, we're going to bump him to the right, which is this vector2.right times hurt distance, etc., using his rigid body dot add force. Lastly, we will set is hurt to false after we've done that. Horizontal movement on the x-axis. So we haven't even begun to actually relocate him. Now we start to check for walking movement. So we take our transform.position and we set it equal to transform.position plus the vector3.right times the x movement, which is a float that we funneled in here, times the speed of this pawn, which is designer friendly. And if he is not jumping in that instance, we will set the walk animation. If he is jumping, then we will set the jump animation. So if his x movement is not equal to 0, in other words, he's moving, and he's grounded, which is a Boolean value. I don't remember describing that. Where did this come from? I know I have it. I think we have it in our, it's a pawn thing. We inherit this. I should have left my pawn script up, and I will go grab it. We inherit a lot of variables from our pawn script. There it is. Public Boolean is grounded. All right. I'll address these as they pop up because I don't want to break my flow here. Right then. So, if we are moving, so in other words, we're not idling at 0, and we are grounded, and we are not hurt, then we will play our walk animation. If we are idling, or we're at 0, 0, there's no input from left or right axis, or the horizontal axis to the left or the right, and he's grounded and he's not hurt, we will play the idle animation. If none of those things are true, we're going to go look at, well, actually, that's not necessarily the correct thing to say. Next on the checklist, I should say, jumping. If jump is equal to true, okay, then we're going to check some more things. So jump's equal to true. In other words, within this frame, the player has pressed the jump button. Okay, well, if he is grounded currently and he is not hurt, then we're going to go ahead and add force times our jump force, which once again is designer friendly. We set our animation to jump, which is when he has his wings up and he just kind of floats there for a second. And then we play the jump sound, which is on our pawn itself. We increment our jump count, which counts how many times the player has jumped in between being grounded. And then we set is grounded to false, since we've just tossed him into the air. We know for a fact he's no longer grounded. And then, if the player is pressing jump, but he's not currently grounded, then he's trying to double jump. So, he's not grounded, he's not hurt. We're going to check how many jumps he has left to use. So, if his jump count is less than the maximum amount of jumps, which is also designer friendly, then we can jump. And if not, then no dice. So, we don't even need anything else after that. There doesn't need to be an else statement because there's no code that executes, it simply continues. Anyway, if, for example, our jump count is 1, max jumps is 2, then yes, 1 is less than 2, we can jump. But if we've already jumped twice, since we were not grounded, then no, we cannot jump anymore. Anyway, we add jump force once again with a vector2.up, and we play our jump animation, play our jump sound, increment the jump count, and life goes on. Lastly, what is going on? This thing. This load player to pawn. There it is. I knew that wasn't a typo. Okay. This was something that I was trying to do with the destroy unload and all of that good jazz. But as you can see, this is not actually necessary, as I had suspected. So we'll go ahead and just get rid of that. Alright then. What we haven't talked about, let me go ahead and check on these variables. We talked about speed, jump force, rigid body is grounded, max jumps, jump count. The animator on this object is flipped, and the spawn point is irrelevant as well, because that was having to do with the destroy unload stuff. So, these are the variables that are inherited by the children of pawn, which you just saw in code. So that's not very fancy at all. What we do need to talk about is his foot script, foot trigger right here. So these platforms, open, have colliders on them. That's what keeps the penguin from falling through the floor. If we grab each platform, they are comprised of these different pieces, which allows us to build them within the editor without having to like stretch them. Like this platform is simply a block left and a block right with multiple centers, as opposed to this one, which I believe just has one. Anyway, they all have their own box collider on them, which is nice. And we call code based on if the player can detect that box collider. So there's no code actually on the platform itself, but now we can look at his foot script. If we click on the penguin, this trigger box right here is the foot script of the penguin. It is a child of this pawn. So as you can see, it's a trigger, it's not a collider, and it's just the script. It has a parent, which we access here so that we can set some variables and things like that. So it's public, and then we also have a private integer called count in trigger, and that was to make sure that there was no objects within the trigger. I was having some issues with that as well. So we're going to have a on-trigger enter and an on-trigger exit, as well as an update function. So when something enters this trigger, we're going to add it to the count and trigger, which means we are indeed standing on something. And then we're going to set is grounded, which is a variable within pawn, to true. Okay. So this parent has this variable on it, etc. Okay. We're going to set our jump count, which once again, this variable is stored within the parent pawn, to 0, because we are grounded. We are standing on something. There's something in this trigger box. In the other case, on trigger exit 2D, we're going to decrease the count in trigger. And then when that count is 0, we are, well, less than or equal to 0, then we are not grounded. There's nothing beneath your toes. You're in the air. So that's what the foot trigger does, and that this is grounded is relied heavily upon for our animations through code, as you saw before. Okay, that concludes the player pawn. What else in this level do we need to discuss? The end. Okay, this is a special instance. It's taken from checkpoint and modified. So as you can see, it's scaled up doubly. So it's scaled to 4 as opposed to being scaled to 2. That end text does nothing, it's just sitting there as a sprite. but we do have the exact same checkpoint script, which is fine because this is the last piece of the game, and if the player wants to replay, then everything is destroyed and reloaded as it is in its initial state, and our checkpoints get reset. But the benefit of having this checkpoint script on here is that it's already primed to play a sound upon the trigger entry. So we just update our audio source, which the checkpoint prefab already contains, and rather than playing the checkpoint sound, we play the wind sound effects. Wind sound effects, which is this, as opposed to this. So that's the regular checkpoint, and the other one was this wind effect. Wind effect. Can't speak today. Anyway, so that's just using things we already had in place, which is nice. And then this box collider was already in existence. Lastly, we do have a victory script on this object, which makes it different from a typical checkpoint, because this is the end of the level. Now, if we go ahead and grab the victory script out of our gameplay folder, we can see that we go ahead and, is this a victory script? Yes, it is. Grab our sound, or excuse me, not our sound. We have our own sound here, but we want to grab the sound off of our audio manager, which contains our level music. So, oh, I haven't talked about the audio manager yet. Okay, we're going to talk about that next. Anyway, this plays not on Awake, but it is played through this script, which will allow us to use this for other levels and stuff if we wanted to later on. Anyway, let's not get distracted here, the checkpoint. So we go to our audio manager .instance, and we tell it to please stop the scene music so that we can play our own sound, which we do call through the checkpoint script. So we don't need to actually play our sound within this script. It's done in the checkpoint script, but we do need to know how long the clip is. So that's why we grab the component, and then we use invoke again, which is like my new favorite function. And we're going to use this method right here, which is invoke victory, which is simply loading the victory screen because we implemented this Unity engine .scene management after the number of seconds it takes to complete my clip, which is located on the My Sound audio source. So once again, nothing too fancy, but that's what it does. Loads the victory screen. Right, I promised the audio manager. Into our managers. And here we go. So, the first thing we did was made this a singleton, so there can be no more. It is a public static. I do end up destroying this on load. As you can tell, I've commented this out because we only have one level, and things were getting awfully rambunctious with destroying things and trying to reinstantiate them and not having things hooked up correctly in the inspector in regards to public variables. So that's something that I should probably research a bit more. Anyway, this is our audio manager, and it contains an audio source as well as a clip called scene music. We could, if we chose to, funnel other or set scene music equal to other clips, and then storing that value, play it through the same line of code. So on Awake, oh, that's just our singleton. That's not fancy. If we don't have anything stored within the instance, oops, my thing is gonna die. That's okay. If we don't have anything stored in the instance, we're going to store this. Otherwise, if something is already occupying it, we'll just store the second one. On start, we're going to get our components, set them into our variables, so the audio source, the scene music clip, which is already stored in audio source, but we're going to set the clip within the audio source equal to the scene music clip, which is public, so the designer could load whatever they want to start out with, and then we're going to play our scene music, which is a function right here, which is simply playing the audio source. Okay, all of these public variables can be called by other objects within the scene. So, we can set the scene music by taking in a new music audio clip as a parameter, setting that or loading that into the scene music variable, and then taking our clip and loading it once again with that scene music. I'm going to grab my charger for my headphones really quick while I continue to talk on this video. We can also play scene music, I already talked about that one. And then we have pause scene music as well, which simply pauses it. We have a stop scene music. There's nothing too fancy going on. And then this plays one shot. Okay, so this was a unique instance where we have this specifically for the pickups because playing clip at point was making it awfully distorted. Where we take an audio source called sound as a parameter, which is actually a child object, this rainbow coins audio. All that is an audio source and a transform. That's it, and some settings. But we grab that and we play it. Simply just play a one shot of it, rather, so that you can play multiple of those. Like if there was a string of coins, not that I've designed it that way, but it would go ding, 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 as opposed to like ding, wait for it to finish, ding. Like it's more responsive and much more better. So, that was that script. Let's go ahead and go through here. Looks like I've talked about everything. Managers, gameplay, controllers. AI controllers empty. That's just kind of waiting to be used. Alright then. That's all of our scripts. That's the level. That's the functionality. The build is in the repo, so if you would like to play it, feel free. And let's just go ahead and check off all of our things here. Oops, that's my credits. Oh, okay, real quick. Art credits. I got a package from the Unity Assets store, so all of the art assets were from the 2D Penguin Runner art by Factory. Level sounds. This, I used a variety of things from him. So the level music, I believe, was Happy something or other. By Dmitry Zbenov, and he has, I'll just show you quickly, assets music. It was actually really nice. He had MP3 files, OGG files, and WAV files. I chose to use the WAV files because I read that the MP3 files could be problematic and cause popping on loop, so I chose WAV files instead and deleted the MP3 and the OGG folders. This is Happy Loop is our level. Happy Walk is the victory. This is the win effects for the end game. Game over falling through is right here. The game over screen, and our Happy Walk is our victory screen. So those are all accredited to him. When the player lands on a spike, that sound I got from Penguin 02. It was actually called Penguin 02, which is kind of nice, by Maddox from freesound.org, using the same asset. I lowered the pitch for the jump. I raised the pitch for landing on a spike, but it was the same sound asset. Rainbow Coins, picking up, was called Coin 7 by Schnorr. I elevated the pitch a bit, and then a sound asset called OK by Scrampunk at freesound.org I used purely as it was for the checkpoint sound. So those are my credits, and I believe I was on a mission to show you something else. No, I was on a mission to make sure we talked about everything. Okay, gravity, detect flares grounded, animations, sounds and music, scenes, start screen, video, last screens, checkpoints, and creativity. And we have talked about that, left and right, gravity, grounded, double jump, animations, sounds on player death, music, well, spikes, jumping, rainbow coins, checkpoint, victory. Music is in all of these scenes. We do have multiple scenes, which these two items are closely related. We have 4 of them, which are the victory, the start screen, the fail screen, and the level itself. We have checkpoints. It is bug and error free for the most part. Commentation is throughout. It is very organized. And our extras, we have a fall zone death, we have invisible walls, we have damage spikes that affect the pawn animation, which the animation is also an extra thing in itself. So I should maybe put damaged animation there. Oh, it uses gravity to place on the ground. I didn't talk about that. So I will go back really quick. As you can see, all of these spikes are above the platform. But in the game, they're on the ground. That is because they weigh a ton, and the player cannot move them. They have a mass of... Where is the... Oh, I'm not even on... It's a fall zone. I would like to grab this object, please. Thank you. Rigid body. A mass of 1,000. And they're supposed to be locked in the X and Z positions. Without that mass of 1,000, it was still pushable left and right, which was interesting, but you can't move it now because it's really heavy, and of course you can't move in the Y animation or Y axis either. Well, it can actually, it can. That's why it falls. Pardon me. It drops down, but yeah. So they fall. They're placed exactly on the ground, and that's where they stay. So that was part of. Since gravity was a focus also of this project, part of the extras, damage animation of the penguin, spinning rainbow coins because we used a rotator script, assets, scripts, gameplay, rotator, simply calls an update for transform.rotate to a new vector 3, taking in degrees to rotate as the Z for that new vector. And it's defaulted to 90, which is outrageously fast. In the inspector, I have the prefab set to 3.5 degrees per frame. But it is kind of cool, actually, to see them spin at 90 degrees. They're, per frame, look like little windmills. Anyway, the next item that was extra, collecting item script is dynamic, so that public drop-down, it's not just the star coins. It can be used for other objects that don't exist yet, but may in future iterations. The UI, so the, well, I suppose live, okay, so the UI being lives and the coin counter. And then lives in general as an entity, like the concept of the player having lives as opposed to just succeeding or failing. And then, oh, didn't show you the camera. Okay, designer-friendly camera controller. This actually helped a lot in fine-tuning the game. So, if we go ahead and play, let me grab the camera so we can have a look at this. Main camera. This camera controller does not inherit from an actual controller thing. It's mono behavior, but, you know, whatever. It is attached to the pawn, and, oh, I'm sorry, this is the controller. Where's my camera controller? Here we go, mono behavior controller. Okay, we grab the pawns, transform. Okay, so public transform pawn TF. We have a public float, which is the designer-friendly part, is offset X, and another one called offset Y. On start, nope, ignore that. Don't need that whatsoever. On the update, we're going to take our the camera's transform position, and we're going to set it to a new vector 3, which is our pawn's transform position.x plus our offset, so whatever the designer decides, our pawn's transform position.y plus an offset of y, which whatever the designer decides, and then the current position of z. So we're not going to be zooming in and out at all. But these offsets really do change up the game from a design standpoint. So if we play, grab our camera, and start to edit things. So we have our offset, there's a 0 right now of x, and a 1 on the y. I said 3. Okay, I can start to see greater distances in front of myself. 5, let's go 10. Oops, not 41. 10, 15. Okay, so I can see far ahead. I can start to plan out my movements, but if I miss something, it's going to be far behind me and I may forget about it. I may forget to go back. I may not have realized that I missed it. If I do want to go back, for example, after jumping over one of these spikes, I can't tell what's beyond it, which is why it is important for the designer to be able to affect where the camera goes. I liked it at 0, so that's where I put it. Same thing goes for the Y position. So if I put it to 10, I'm on the ground here, which is fine, but then I jump and I can't see what's under me. I don't know where to land, and I don't know if there's any platforms below me. If I put it at -5, I can see what's below me, but in a position like this, it might be a little difficult to see any obstacles like that one. Which, if the designer wants that, that's fine. And then if I have like any extra coins up here, I can't see them. Which, once again, maybe that's a design point, but as a programmer, providing the most amount of flexibility is what I'm trying to do. Because I'm also a designer, and I would much prefer to have some flexibility in like things that I can edit and modify and tweak. So that's where we're at with that. I do recall that I did not show you properly the checkpoints. So here's this one very distinct checkpoint where we have 2 platforms kind of on top of each other. So I just want to jump back and show you that that does save. Alright. Unique checkpoints. Oh, that's the end point. And then that'll load our victory. Alright. Let's try that again. There we go. And here we are back at start. Alright. So that's where we're at with that. That should conclude. It does. Conclude the project. Thank you very much for watching the milestone video for Project 4.